Today's lesson is on scientific notation. As the name suggests, scientific notation is used mostly in science for really big numbers and really small numbers. Now, like a lot of the math that you're learning right now, this is going to come back and you're going to be using this again and again and again all throughout your middle school and your high school careers, especially in physics and especially in fields like biology where you're working with really small numbers, or chemistry. So let's look at an example of how we would write a number in scientific notation. If we have a really large number like 6,700,000,000, we wouldn't want to write that number every time that it came up. We want something a little more smaller, something quicker to write. So what we're doing is we're multiplying by a power of 10. So our second factor, our second number we're multiplying, is always by 10, and we need to use an exponent. For this one, we have one of two ways. We can either count by threes by using the comma, so 3, 6, 9, or we can count individually. 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's to a power of 9. Anytime you have a large number and you're moving your decimal point over to the left, the exponent will always be positive. Your first factor, your first number, needs to be greater than 1, but less than 10. Alright, so this is 416,800,000. Starting from the right, we're counting over 1, 2, 3, 4, 5, 6, 7, 8. So I'm multiplying by an exponent of 8 to the 8th power for 10. And our decimal point is between the 4 and the 1, so it's 4.168. So that's for a really large number. It goes, same principles apply for the really small numbers. So if we had this number, 0.000009 or 9 to the, I'm not really sure what, but we'll just stick with that. I need to get this decimal point over on to the right of the 9, so I'm moving it over 1, 2, 3, 4, 5, 6. So I've moved it over 6. Difference here is it's going to be a negative exponent. 9.0 times 10 to the negative 6. The reason why this is the case is if you take 10 to the power of negative 1, that actually equals 1/10. So by doing it 9 times 10 to the negative 6, you're actually multiplying 9 times 1 over 1, 2, 3, 4, 5, 6 over a millionth, 1/1,000,000th. One more example. There's another example of this, 0.000314. I need to move my decimal point over between the 3 and the 1. Again, the first factor has to be greater than 1 but less than 10. So I'm moving this over 1, 2, 3, 4, 5. So that's going to be to the negative 5th power. Decimal point is between the 3 and the 1, and I have a 4 here after right. So it's going to be 3.1 times 10 to the negative 5th. Now this also works in reverse, going from scientific notation to standard notation. I have 3.51 times 10 to the 3rd. Basically what that is 3.51 times 10 to 1, 2, 3 to the 1,000. I could write 1,000, or I could just realize the 3 indicates how many place values I need to move the decimal point. So if I start at the decimal point, I move it to the right, 1, 2. I don't have a 0 there, I don't have a place value, so I need to put 0 in as a place value, 3. So 3.51 times 10 to the 3rd is actually 3,510. if 3.51 was multiplied by a negative exponent, let's say to the negative fifth power, this is actually just telling me I need to move my decimal point in this direction, to the left. So I'm going to start here, where the decimal point is, and move to the left. 1, obviously there's nothing to the left of the 3, so I need to put some zeros in for place value markers. 1, 2, 3, 4, 5. And I have space there. I've got 1, 2, 3, 4 zeros. I need to put a decimal point here, and it's always good to put a 0 on to the left of the decimal point just to make it stand out a bit. It's pretty much standard procedure.